Hi all, welcome to my course on ozone technology. This will be session 23B on fundamentals of cooling tower water treatment. This session will describe the following topics: continuation of the corrosion. This is electro-galvanic corrosion. Then we shall be discussing something on slime and algae and the importance and effects on cooling tower systems. Next topic will be foaming and frothing, and then followed by drift, the definition of drift and plume and the effects. We will be discussing on bacteria and control of the system, Legionella, the growth and its effects, and water quality and regular water testing. We have discussed other types of corrosion, such as erosion corrosion, chemical corrosion, and biological corrosion. Now, the fourth type of corrosion, which is extremely important, particularly with cooling tower systems, is galvanic corrosion. This is also called bimetallic corrosion because it is an electrochemical mechanism in which, in the presence of an electrolyte and two dissimilar metals, one metal preferentially corrodes when it is in the electrical contact with the other. So corrosion takes place only in the conductive solutions. Chlorides and other electrolytes create this state. The electrolytes, mainly chloride, moves from anode, there is a corrosive area, to the cathode. At the anode end, corrosion takes place. The anode is generally the pipes which start corroding. The typical example of dissimilar metals found in the cooling systems are iron pipes or steel pipes that contain iron, and copper pipes, which are particularly essential in the chillers because copper is a good conductive metal. Galvanic corrosion is so serious it can only be reduced but never be eliminated, unless of course we can make the solution totally non-conductive, which is not economical, or have dissimilar metals, which means copper has to be eliminated, which also is virtually not practical in a cooling system. Of course, we can reduce the corrosion levels by adding corrosion inhibitors and reducing the chloride levels, plus the sacrificial anode or countercurrent systems, which is opposing galvanizing current. Or we also reduce the chloride levels plus ozone treatment and sacrificial anodes or countercurrent systems. This option is in fact the most economical option. As we all know, where there is sunlight and where there is water and where it is mixed with the air, which contain seedlings of or spores of algae, bacteria, etc., they all will grow. Algae is particularly supported by sunlight, and if the cooling towers are situated in direct sunlight with like timber slats being constantly wet, then these slats will grow the algae. Algae can also grow in the water and form strands, etc., which can clog up the chiller pipes and prevent or suppress the flow of the water for cooling. The algae can accumulate so much that it may completely clog up the diameter of the chiller tubes, which will cause the pressure to drop and heat will not be transferred and cause automatic shutdown. In order to prevent algae, it is necessary to add algicides. The picture on the left will show you how bad an algae problem can be, and obviously it can very severely affect the cooling tower system. Algae can also cause biofilm on the sides of the pipes or metals. These algae are small one-cell algae, and they will also be able to harbor bacteria. The picture on the right shows a blown up portion of the side of a pipe of a cooling tower water, and you can see that this part is partly the algae strands, and you may have algae stuck onto the walls, and the little dots would probably constitute as bacteria. Also, you would note that the water can flow onto the gaps in the slime, and where bacteria can be transported from one area to another area, and bacteria can consolidate in the slime, and eventually, depending whether they are corrosive bacteria or otherwise, corrosion can take place along the pipes, eventually causing micro leaks. There is another factor we have to consider in cooling tower water systems, that is foaming and frothing. Foaming can be a serious problem in the cooling tower. But what causes the foaming? As we all know, that in order to maintain the cooling tower free from biocides, corrosion, and scaling, chemicals are added. Many of these chemicals, in fact most of these chemicals, are organic types, particularly biocides. These organic material will cause frothing and foaming when the water flows at very high speeds and is continuously churned. The collection of dust and dirt from the air will also contribute to the serious problem of frothing. The issue, what frothing and foaming does is they create very tiny bubbles which has got a very high surface area, and therefore they reduce the surface area of exposure of water to the heat. In other words, the bubbles become non-conductive to heat. So the actual water contact between the refrigeration liquid and the cooling water is very small, and therefore the heat exchange is inhibited. That will cause reduction in cooling efficiency. In order to resolve this issue, yet another chemical called foaming inhibitors or anti-foaming chemicals are added. This is a typical cooling tower where frothing has taken place. You will notice that the total number of bubbles, the amount of bubbles have created so much that there is hardly any water in the system. Therefore, with the absence of water, the cooling tower in the chillers, there is a reduction in transfer of heat from the compressor liquid to the water. Drift and plume. What is the definition of drift and what is a plume? Drift composes of atomized water droplets caused by churning and scrubbing of the water by the air, which is flowing upwards. The airflow carries this atomized water, which also includes the bacteria such as Legionella, and the wind will blow it away, and that becomes the plume. This plume can be carried by the wind downwards for kilometers. The drifts, besides evaporation, cause water loss that must be topped up. We also can lose water through drifts from the sides as the water is falling down. So normally they install drift eliminators or slats to prevent the excess of water taken away or blown out or falling out of the cooling tower. There's the fan that sucks the air from the outside upwards, scrubbing the water that falls down, the hot water that falls and gets heated up, and it goes upwards in the form of a drift and plume. It is important to note that the temperature of water from the heat exchangers reach up to 45 degrees, that is, the temperature has reached is 45 degrees, and by the time it cools down, the temperature here, cold water, is about 37 degrees. At 37 degree temperature, with a lot of dust, dirt, and etc. that within the water, is extremely good for bacterial growth, and hence for the reason of adding biocides. In order to ensure that we have a very efficient operating system of the air conditioning system, plus in the interest of health and safety, public health and safety, we have to maintain a maintenance program which will look, detect, and treat any bacteria or any other components, parameters in the water that will harm the public through the plumes, etc., or affect the good operation of the cooling systems. So we need to have a regular maintenance program. And we have to have a monthly test of total bacteria, coliforms, to ensure that the water is in reasonably good biological status. Legionella growth, we have to do a test for Legionella every month to ensure that it's virtually absent. The effect of Legionella is well known because this Legionella bacteria very infectious, causes infection on generally the immunocompromised people and aged people that will cause the Legionella pneumonia, eventually leading to death. So it is important that we check for Legionella in every tower to ensure Legionella is not present. But rest assured that if you fail to have a very highly reduced biological systems in the water, the chances of Legionella growing will be very high. For the sake of proper maintenance and operations of the cooling tower, we also need to ensure the water quality with respect to corrosion. So we have to put in corrosion coupons to check that water is not in a corrosive state. Then we have a regular maintenance programs. If you are using the chemical systems, you've got to make sure that all the chemicals are in the right concentrations that are added into the water. We have to do microbiological tests, as I did explain to you, the bacteria and Legionella. The physical and aesthetical, of course, aesthetical obviously is very important. Physical in respect, we might have unsightly algae growth on the sides, on the floors, etc., which may cause slippery states and accidents. Aesthetical, that shows that if it is good aesthetical state, the chances are we have a very good maintained cooling tower. Now, many government authorities have instituted registration of cooling towers and require the building managers to keep regular reports that can be inspected by the health authorities anytime. And these monthly recorded reports must be available to a health department on notice. This registration has become mandatory in New South Wales and possibly Queensland. That is because New South Wales particularly has got very high levels of Legionnaires disease. Please also note that in Australia, any person who contracts pneumonia and dies is automatically tested for Legionnaires disease, and which is not practiced in many other countries, and therefore it is very difficult to identify if a person has been infected because of the poor maintenance of cooling towers. This is a chart that I have devised for better understanding. We have a problem where there is bacteria and algae. A solution is to add biocide and algicide. We get a low bio count, but the undesired result will be increased organics and total dissolved solids. For a problem of corrosion, we have corrosion inhibitors, which will reduce your corrosion, but we have to increase blowdown because of chemicals in evaporation and drift. Because the TDS is increased. Also, we have the scaling, which is a problem. We had scaling inhibitors, so we have to reduce scaling, but that will cause increased organics and TDS, and we have to increase blowdown. Then we have foaming. Because of addition of all these chemicals, we have to add anti-foaming agents that will reduce the foaming, but at the same time increase the TDS, which will increase the blowdown and increase the water top-up. That will cost, when you increase the water top-up, you are increasing the chemical and water cost. At the same time, you are diluting the chemicals. That will require you to start to add more biocides, inhibitors, and foaming agents to maintain the concentration that is required to stop the bacterial growth, corrosion, scaling, or foaming. If you consider all this, it's better. Ozone is definitely a better solution. In conclusion, water treatment is a necessity. But with chemicals, you have to have leading a cycle of concentration, a cycle of problems, and solutions, ending up with a higher cost. The problems resolved for dire contaminations, corrosion, scaling, and algae. The solution adding chemicals leading to increased TDS, organics, and foaming. That will require to bleed the water to remove the TDS or reduce the TDS. That will cause reduction of water in the system, and you will have to top up with fresh water as a solution. And you will get a further problem resulting of the concentration of chemicals and biocides. So we have to add more top-up chemicals to give back problem number 3. And this cycle goes on in chemical treatment. The only end is higher and higher costs. We have come to the end of session 23B with the traditional chemical treatment of cooling towers. Please proceed to session 24, which will continue with ozone treatment of cooling towers. If you are new to this channel, please refer to session 1 and 2 that will explain the course program, and 3 to 22 for the sessions of program. If you like the course, please click the like icon and subscribe icon when you will be notified as soon as further sessions are released. Thank you and have a very good day.